Welcome to RK Tutorials. In this tutorial, I will explain the concept of bubble sort algorithm, and also I will write C program in the Turbo C environment and I will show the output. I will explain the bubble sort algorithm by taking a suitable example. First, I am considering an array with 5 elements. So I am taking n is equal to 5. And let those elements are 12, 14, 20, 16 and 4. Now my interest is we need to arrange these elements in ascending order. In bubble sort algorithm, the main concept is compare the two adjacent elements. This is the main subprogram of the main program. A of j is greater than a of j plus 1, then we need to swap those two elements. That means at the first step, I will compare 12 and 14. I will take j is equal to 0. Then I will compare 0 and 1. So if my j is equal to 0, then my j plus 1 becomes 1. So I will compare 0th element with the first element. If a of 0 is greater than a of 1, then I will swap. If not true, then those elements will kept as it is. So 12 is not greater than 14. So first I will compare these two elements. Since 12 is less than 14, so I will keep those two elements as it is. Next I will take my j is equal to 1. 1 means, so my j is equal to 1 means I need to compare the first element with j plus 1 element means second element. So first and second elements are to be compared. So whether 14 is greater than 20? No. That means, so I am comparing these two. Since 14 is not greater than 20, so I am keeping those two numbers as it is. In the next iteration, I will take j is equal to 2. If I take my j is equal to 2, then I need to compare second element and third element. My second element is 20, third element is 16. I need to compare 20 with 16. Whether 20 is greater than 16? True. That means swap the values. That means here 16 occupy this position and 20 is occupy this position. Next I will take j is equal to 3. That means I need to compare the third and fourth elements. J and j plus 1 elements are to be compared. That means third element is to be compared with the fourth element. Whether 20 is greater than 4? True. That means swap those two elements. So 4 and 20 occupy this position. So this will be considered as the first iteration. The first outer loop, you can say. This is first outer loop iteration. So at the end of the first outer loop, the heaviest element occupies the last position. All these are the inner loops and the total thing will be the outer loop. Now let us consider the second outer loop. The second outer loop. So before entering into the second outer loop, my array is like this: 12, 14, 16, 4 and 20. The 20 is already in its position. I need not to compare this 20 with any of the element. Now I need to compare only these 4 elements. Inner loop once again starts from j is equal to 0. That means 0th element is to be compared with the first element. Whether 12 is greater than 14? No. So these 12 and 14 occupies the same positions. Next j is equal to 1. That means the first element is to be compared with the second element. Whether 14 is greater than 16? No. So 14 and 16 occupies the same position. Next I will take j is equal to 2. That is second element is to be compared with the third element. Whether 16 is greater than 4? Yes. Then exchange these numbers. So 4 occupies this position, 16 occupies this position. So at the end of the second loop, at the end of the second outer loop, the second largest element occupies his position. Let us go to the third phase or third outer loop. Before entering into the third outer loop, my array position is like this: 12, 14, 4, 16 and 20. These two elements are occupies its positions. Now I need to compare only these three elements. Once again, J starts from 0. 0th element and first element will be compared. 12 is greater than 14. No. So 12 and 14 occupies this position, their own positions. Next, J is equal to 1. Here 14 and 4, first element and second element will be compared. Here whether 14 is greater than 4? Yes. Then it should be exchanged, that 4 and 14. Now the third element occupy its correct position at the end of the third outer loop. Next, go to the fourth outer loop. In the fourth outer loop, before coming into the loop, the initial position is 12, 4, 14, 16 and 20. Once again, J starts from 0. So 0th element and first element is to be compared. Whether 12 is greater than 4, true, then exchange it. So 4 occupies the first position and 12 occupies the second position. And this is my final answer. Okay. So the important points we need to remember is, since n is equal to, I have taken 5, how many outer loops we need to execute? This is the first outer loop, second outer loop, third outer loop and fourth outer loop. So 4 outer loops is to be executed. And for each outer loop, now you can see here in the first outer loop, there are 4 inner loops are to be performed. In the second outer loop, only 3 inner loops is to be performed. In the third outer loop, only 2, and in the fourth outer loop is only 1. This is the concept. Now I will explain the same thing by writing a C program in the Turbo C environment. Let us write the C program for bubble sort algorithm. Let me save my file first in C prompt, pub.c, say OK. Now let me write the program. Hash include stdio.h, hash include std lib.h, hash include conio.h, void main. I am initializing some of the required variables. I am taking array A with 20 elements. And I am taking J, N, some temporary variable, let us say T. Let me clear my output screen by using clear clr. Now enter the number of elements in the array. Scanf %d and n. Let me take all those elements into the array. Printf enter the elements. Enter the elements into an array for I is equal to 0, I less than n, I plus plus. Since there is only one line statement, these braces are not required, but to easily understand for the beginners, I am writing the brackets also, and a of I. That means we have taken all the n elements into the array. Now let us start the sorting algorithm. For I is equal to 0, I less than n is sufficient, I plus plus. And the outer elements for j is equal to 0, j less than n minus 1 minus I, as I explained in the theory. Only these many number of operations are sufficient for inner loop. The main concept, if a of j is greater than a of j plus 1, then we need to swap. What is the what is the concept for swapping the numbers? T is equal to a of j, a of j is equal to a of j plus 1. Let us write the program beautifully by using some tab commands. A of j is equal to a of j plus 1 and a of j plus 1. I am closing the if statement, then I am closing the j statement, then I am closing the I loop. Now let us print the sorted array, printf. Printf session then how to print? By using the same statement. For I is equal to 0, I less than n, I plus plus, then I am using printf percentage t a of I, then I will use tab to easily understand. I will also use some getChar command so that I can see my output without any disturbance. So this is my program. So let me run the program. Let us see, is there any errors? No, it is completely free from errors. And I am giving 5. Enter the elements 12, 14, 16, 20 and then 4. And the sorted array is 4, 12, 14, 16 and 20. It is arranged very beautifully. Okay. Now let us give in another input. Let the numbers are, let it is a 10 elements array and it is 12, 18, 16, 7, 2, 24, 86, 9, 11, 34. See, the sorted array is 2, 7, 9, 11, 12, 16, 18, 24, 34, 86. Very beautifully it was arranged. Now the same program you can also use it for descending order. Do you know where is the change? Instead of greater than, if I just place here less than. The same program you can use for descending order. Same program you can use for descending order. That means if I use less than here, I am not changing any of the program, just I am changing instead of greater than, I am just using less than. Let us see what happens. I am using 5 elements to understand. Same 12, 14, 16, 20 and 4. And they arranged are in the opposite direction, 20, 16, 12, 14, 12 and 4. The same program. I have not changed any of the program, my dear students. Just instead of greater than symbol, I used less than symbol. Then the total program becomes descending order.